This is the enzyme tail of a beta-galactosidase star in the Beta-galactic galaxy. In a faraway land tucked away in the small intestine of human beings, the Beta-galactic galaxy exists. In this galaxy, small meteors named lactose travel through the corridors of the small intestine. Lactose is a carbohydrate meteorite made up of two separate meteors fused together. In scientific terms, lactose is a disaccharide. It is a glucose and galactose monosaccharide held together by a 1,4-glycosidic linkage. One day, lactose was journeying through the Beta-galactic galaxy. As they flowed through the speckled sky, they couldn't help but be distracted by all the twinkling stars. Suddenly, before they realized, galactose had flown too close to a star, and they were traveling too fast to stop. This star was named Beta-galactosidase. Beta-galactosidase is an enzyme that is a homotetramer, meaning it has 4 identical polypeptide chains. Each chain is 1,023 amino acid residues long. 5 structural domains exist for each chain. Beta-galactosidase wasn't an unknowing victim of a collision. It was a calculated plan all along, because their third domain is an alpha-beta barrel. The C-terminal of this barrel forms the enzyme's active site. Near the active site, there is a magnesium cofactor. This magnesium ion is essential to the catalytic mechanism because ligated to it are several amino acid residues that stabilize the lactose substrate. Beta-galactosidase wanted the lactose meteorite to strike this site in the correct orientation so that they could carry out the rest of their mechanistic plan. Unluckily for lactose, they struck the star so that its galactosidic portion could form several interactions to stabilize its binding to the star. Once the meteorite was bound to the star, they thought, "This can't be that bad. We're still on the surface, and if we use all our strength, maybe we can escape this evil star." When suddenly they began to move further into the star's active site. Lactose had shifted from the shallow mode of binding to the deep mode of binding. Hydrogen bonds and other interactions held the lactose in the active site. Lactose was positioned beneath glutamate 461 and above glutamate 537. Glutamate is an amino acid residue with a side chain containing a carboxylic acid group. The first step of the mechanism is galactosylation. The lone pair of electrons on the glycosidic bonding oxygen attacks the hydrogen of glutamate 461. The negatively charged oxygen of glutamate 537 acts as a nucleophile and attacks carbon 1 of the galactosidic portion of substrate. This movement of electrons leads to transition state 1. The glycosidic bond between galactose and glucose is being broken. The glycosidic oxygen forms a bond with the hydrogen of glutamate 461, allowing glucose to dissociate from the enzyme substrate complex. The galactose portion covalently bonds to glutamate 537, allowing the formation of this covalent intermediate. Galactose, now strongly bonded to the star, watched his once conjoined meteorite hurtle out of the active site and away from himself. Now he was all alone. The second step of mechanism is degalactosylation. The lone pair of the oxygen in a water molecule attacks carbon 1 of the covalently bonded galactose substrate, while glutamate 461 steals a proton from the same water molecule. During this action, the covalent bond between glutamate 537 and substrate is broken. This step leads to the short-lived existence of transition state 2. Where a glycosidic bond once existed, galactose now had a new hydroxyl group, and he was freed from the enzyme. Right when he exited the beta-galactosidase star, he saw his best friend waiting for him. While they were no longer conjoined by a 1,4-glycosidic linkage, they had been reunited. The lactose disaccharide was now separated into galactose and glucose. So, to summarize what happened, the lactose meteorite collided with the beta-galactosidase star. They did this in such a way that the active site could stabilize the substrate once lactose binded in the shallow mode. Beta-galactosidase acted to pull it into deep mode. In the deep mode active site, beta-galactosidase hydrolyzed the bond between glucose and galactose. First, glucose was released after galactosylation. Then, galactose was released after degalactosylation. The monosaccharide meteorites continued joyfully on their journey through the Beta-galactic galaxy. They lived happily ever after, until they found out about glycolysis.